Elon Musk just exposed a fatal flaw in SpaceX's Raptor engine. The same engine supposed to save humanity on Mars is secretly bleeding 5% of its power every single flight. But wait, engineers found something incredible. This flaw could actually unlock 5.3% more performance. How is that even possible? Let's dive right in. Here's what actually happened. Every Raptor engine that's ever launched has been deliberately sabotaging itself, and Musk knew it from day one. Let's start with something that'll blow your mind. The Raptor engine uses a full-flow staged combustion cycle, a technology so insanely difficult that it was considered impossible for decades. NASA tried it, the Russians tried it, everyone failed, until SpaceX didn't. But here's the crazy part. This impossible technology is exactly what's causing the 5% power loss. Those preburners I mentioned, they're literally mini engines inside the main engine, burning fuel before it reaches the main chamber. It's like having two stomach acids digest your food before it gets to your actual stomach. Every rocket engineer on Earth told Musk this was stupid. Why would you want to burn your fuel twice? Why would you intentionally reduce your engine's power? But Musk had a different plan entirely. Here's what changes everything. Traditional rocket engines are like Formula One cars. Incredible performance, but they explode themselves after one race. The space shuttle's engines needed complete rebuilds between flights. Now imagine you're on Mars, 140 million miles from the nearest mechanic. Your Raptor engine fails. What do? Call AAA. This is why SpaceX made the most controversial engineering decision in rocket history. They deliberately crippled their engine to save it from itself. Those pre-burners that steal 5% of the power, they're actually cooling the engine down, reducing stress, extending its life. It's like choosing a Toyota over a Ferrari for a cross-country road trip. Less exciting, but you'll actually make it to your destination. But then SpaceX engineers discovered something that changed everything. Remember how I said the engine loses 5% of its power? Well, what if I told you they found a way to not just recover that power, but make the engine 5.3% more powerful than it would be without preburners? Here's how they did it. By adjusting the fuel mixture ratio from 1.11 to 1.4, something magical happens. The engine doesn't just compensate for the preburner losses. It actually becomes more efficient than a perfect engine would be. But wait, it gets weirder. You'd think more power means more heat, right? Wrong. At this optimized mixture, the temperature actually drops by 6.4%. It's like discovering that driving faster makes your car run cooler. This is where physics starts breaking down. But there's a catch that could destroy everything. At that magical 1.4 fuel ratio, the pressure inside the combustion chamber jumps by 5%. And this is where SpaceX hits a wall made of the laws of physics themselves. Current materials, even the most exotic metals on Earth, can't handle much more pressure. SpaceX already uses Inconel, a superalloy that costs more per pound than gold. They even invented their own metal called SX500 that can withstand 800 atmospheres of pressure. To put that in perspective, the deepest part of the ocean only creates 110 atmospheres. SX500 can handle the pressure of 8 kilometers of water, pressing down on every square inch. And it's still not enough for what they really want to do. While other companies are still machining parts like it's 1950, SpaceX is literally printing rocket engines. Not just small components. Entire engine sections are being built layer by layer in 3D printers. This isn't just cool technology, it's strategic warfare. Traditional manufacturing takes months. 3D printing takes days. When you're trying to get to Mars before your competitors even figure out how to land a rocket, speed isn't just an advantage, it's survival. But here's the part that should terrify every other rocket company. SpaceX can now integrate dozens of separate parts into a single printed component. Those complex cooling channels that used to require assembly of hundreds of pieces, now they're printed as one solid unit. Your competitors can't even see how you did it anymore. This is where the story gets absolutely insane. Remember that flying spaghetti monster, Raptor 1, with all its cables and complexity? It produced 1,700 kilonewtons of thrust, Raptor 2 jumped to 2,250 kilonewtons while cutting production costs in half. Impressive, but not shocking. Then came Raptor 3, and this is where physics starts crying. 2,800 kilonewtons of thrust. That's a 65% increase over the original. But here's the kicker. It's 36% lighter than Raptor 1. More power, less weight. That's not just improvement, that's magic. Look at this thing. It looks like someone stripped away everything unnecessary and left only the pure essence of rocket engine. It's so clean, so minimal, that when SpaceX first showed it, other rocket CEOs thought it was fake. But Musk isn't done. He's hinting at pushing beyond 3,000 kilonewtons. That's almost double the power of the original engine. Here's something most people completely miss. The Raptor can swivel 15 degrees in any direction. Doesn't sound like much? It's actually revolutionary. The Space Shuttle's engines maxed out at 12.5 degrees. Falcon 9's Merlin engines can only do 5 degrees. But Raptor's 15-degree range isn't just about steering, it's about surviving the impossible. When you're landing a 120-meter-tall skyscraper on a floating platform in choppy seas, or trying to catch it with mechanical arms, moving at precisely the right moment, those extra degrees are the difference between success and a multi-billion-dollar fireworks show. But the range isn't even the most impressive part. It's not just how far the Raptor can move, it's how fast it moves. During Starship landings, engines shut down one by one in a carefully choreographed sequence. The remaining engines have milliseconds to compensate. This happens while the entire rocket is experiencing massive G-forces, traveling at supersonic speeds, with the ground rushing up at hundreds of miles per hour. It's like performing heart surgery while riding a roller coaster during an earthquake. One small delay, one miscalculation, one engine that doesn't respond fast enough, and 33 crew members don't make it home from Mars. This is where the real battle is happening. Not in space, not on launch pads, but in metallurgy labs where SpaceX engineers are literally inventing new forms of matter. They've created alloys with names like 6500 that can survive conditions that would vaporize normal metals. These materials are so advanced, so proprietary, that SpaceX guards their composition like nuclear launch codes. But even these miracle metals have limits, and SpaceX is pushing right up against those limits with every iteration. So here's what Musk finally revealed. The pre-burner Flaw was never a flaw at all. It was the foundation of the entire Mars colonization plan. Every inefficiency in the Raptor is actually an investment in humanity's future. Lower combustion temperatures for longer engine life, reduced peak thrust for better control, complexity for reliability. SpaceX isn't just building an engine. They're building the transportation system that will make our species survive beyond Earth. The pre-burners that steal 5% of the power? They're the reason Starship can launch, land, refuel, and launch again. They're the reason the same engine can work on Earth, in the vacuum of space, and in the thin Martian atmosphere. They're the reason we're going to Mars. But there's one more revelation that changes everything we thought we knew about SpaceX's real plan. NASA engineers are speechless. Axiom Space just dropped a bombshell. A fully completed module that shouldn't exist until 2030 is sitting in their facility right now. They've scrapped their entire 2025 launch plan because they discovered something that changes everything. The race against China just became life or death for America's space dominance. What forced Axiom to abandon years of planning overnight? The answer will blow your mind. Let's dive right in. Here's the moment that changed everything. January 15th, 2025. NASA engineers walked into Axiom's Houston facility for a routine inspection. What they found sitting in Bay 2 made their jaws drop. A fully completed multi-purpose logistics module, gleaming under the industrial lights, ready for space. This module wasn't supposed to exist until 2030. The official timeline had it listed as future development. But there it was, 4.2 meters in diameter, 6.7 meters long, weighing 15,000 kilograms of pure American space engineering. The NASA team couldn't believe what they were seeing. "How is this possible?" one engineer whispered. The answer would shock the entire space industry. 3 weeks earlier, intelligence reports started flooding into NASA headquarters. Russia was preparing to withdraw from the International Space Station program, potentially as early as March 2025. Not 2030 as planned, March 2025. If Russia pulls out, the ISS becomes a death trap. Without Russian Soyuz capsules for emergency evacuation, without Russian Progress cargo ships for resupply, without Russian attitude control systems, the station would spiral into uncontrolled descent within months. America would lose its only foothold in space overnight. Every experiment, every research project, every astronaut mission, gone. The Chinese would be alone up there, claiming victory in the ultimate high ground. Axiom Space saw this catastrophe coming months before anyone else. While NASA was still hoping for diplomatic solutions, Axiom was secretly building lifeboats. Here's where Axiom made their most brilliant and terrifying decision. They completely scrapped their original launch sequence. HAB-1, their crew habitat module, was supposed to launch first in 2025. It's been ready for months, sitting in final testing. But Axiom said no. Instead, they're rushing the PPTM, the Payload Power Thermal Module, to the front of the line. This decision cost them $847 million in schedule changes and manufacturing retooling. Why would they burn that much money? Because the PPTM isn't just a power module. It's a complete life support system packed into 18 tons of cutting-edge technology. Built by Thales Alenia Space in Turin, Italy, it contains 47 different subsystems, 12,000 individual components, and the most advanced thermal regulation system ever created for space. With HAB-1 and PPTM together, Axiom Station can operate completely independently. No Russian support, no political complications, no backup plans needed. Just pure American space dominance, floating 400 kilometers above Earth. But here's the terrifying part. Intelligence sources suggest Axiom only has until August 2025 to get these modules in orbit. After that, the ISS becomes too unstable to support construction operations. Remember that mystery module in Axiom's facility? It gets even stranger. Satellite imagery from December 2024 shows Axiom's Houston complex was completely empty. No modules, no major components, just assembly bays and manufacturing equipment. 6 weeks later, a completed MPLM appears like magic. How do you build a space-qualified module in 6 weeks? The answer lies in Axiom's most closely guarded secret, parallel manufacturing. While everyone thought Axiom was building modules one at a time, they were secretly running 4 parallel production lines. HAB-1 in Bay 1, PPTM components in Bay 2, research and manufacturing facility parts in Bay 3, and the mystery MPLM in a hidden Bay 4 that didn't officially exist until last month. This approach required 3,400 specialized workers, $2.1 billion in advanced manufacturing equipment, and production techniques borrowed from Tesla's gigafactories. Each module uses 847 custom-machined titanium components, 15 kilometers of specialized wiring, and thermal protection systems that cost $50,000 per square meter. The result? Axiom can now produce space station modules at a rate nobody thought possible. While competitors need 18 months per module, Axiom is targeting 6 months. It's like comparing handcrafted furniture to automotive assembly lines. While America has been struggling with ISS politics and budget constraints, China has been quietly building an empire in space. Their Tiangong station isn't just operational, it's thriving beyond anyone's expectations. Right now, 3 Chinese astronauts are conducting 127 different experiments in zero gravity. They're growing perfect protein crystals for pharmaceuticals, manufacturing fiber optic cables impossible to create on Earth, and testing technologies that could revolutionize everything from computer chips to medical devices. Even more alarming, China just announced plans to expand Tiangong from 70 tons to 180 tons by 2027. They're adding manufacturing modules, research laboratories, and permanent crew quarters for up to 12 astronauts. If Axiom doesn't launch soon, America could find itself looking up at a Chinese-dominated sky. The implications are staggering. Scientific breakthroughs, military reconnaissance capabilities, asteroid mining rights, satellite deployment advantages, all controlled by Beijing. Pentagon analysts estimate that Chinese space dominance could shift global power dynamics more dramatically than nuclear weapons did in the 1950s. The next superpower won't be determined by armies or navies. It'll be determined by who controls orbit. Just when Axiom thought they had a clear path to victory, a company called Vast Space emerged from stealth mode and dropped a bombshell. They're launching Haven 1, their first commercial space station module, in August 2025. Not 2027, not 2028. August 2025. Haven 1 is small, just 8 meters long and 3.8 meters in diameter, but it's also brilliant in its simplicity. No complex multi-phase construction, no dependency on the ISS, no international partnerships to navigate. Just launch, deploy, and start operations. If VAST succeeds, they'll beat Axiom to market by potentially 2 years, claiming the title of first fully commercial space station. Worse yet, NASA is reportedly considering splitting their commercial station funding between Axiom and VAST, potentially cutting Axiom's budget in half. How did this happen? How did an unknown company suddenly leapfrog ahead of Axiom's years of preparation? The answer involves SpaceX, Starlink integration, and a development approach that's either genius or completely reckless. VAST's entire station fits inside a single Falcon Heavy fairing. Their life support systems are simplified to the extreme. Their crew capacity is limited to 4 people maximum. They're essentially launching a space RV while Axiom is building a space city. Here's a connection most people are missing. Axiom isn't just using SpaceX for launches. They're integrating their entire operation into SpaceX's ecosystem in ways that could reshape the entire space industry. Every Axiom module will launch on Falcon Heavy rockets, using proven hardware and established procedures. Every crew rotation will use Dragon capsules, leveraging SpaceX's unmatched safety record. Every communication link will run through Starlink satellites, providing global coverage and unprecedented bandwidth. But the integration goes deeper. Axiom's thermal management systems are adapted from Dragon's environmental controls.